Really important here, we need to remember how to name and write chemical formulas for ionic, molecular, and acidic compounds. So ionic compounds have a metal and a non-metal. It can also be a metal and a polyatomic ion. Really, what we need to have is we have to have a charged particle. So we need a positive and a negative charge coming together and attracting one another because of those positives and negatives. Covalent compounds are two nonmetals and they share electrons. Acids have an H in front of the nonmetal, so H followed by something like HSO4, H2SO4. Or they can end in COOH. So because the H was at the front here, this is an acid. They can be CH3COOH. This is an acid because this H over here. Acids have to have an H. Now, not everything with an H is an acid. CH4 doesn't follow either of these rules. It does not have an H in front, and the last H does not fall from a COOH. So CH4 is not an acid. It is something that's covalent. All right, identify the following as ionic, molecular, or acidic. Take a moment, decide who is and who is not. Pause the video if you'd like. So I'm going to go through and I'm going to identify anything with a metal in it as ionic. Ionic, this is ionic for sure because of these guys. Now, this looks molecular or covalent. However, NH4 is a positive ion and NO3 is a negative ion. So NH4 acts like a metal. Therefore, this is an ionic compound. It's tricky. Okay, I'm going to go look for acids next because they might look a lot like a molecular compound. So acid compounds have an H out front or they end in COOH, and that H is acidic. COOH, therefore this is an acid, starts with an H, this is an acid. COOCH3, now that doesn't follow exactly, so it is not an acid. CH3OH, again, doesn't end in COOH, so it is not an acid. NH3, because it does not start with an H, and it does not end in COOH, is not an acid. Therefore, hopefully the rest of these are molecular. NH3 is molecular. C2H5COO, CH3 is molecular. CH3OH is molecular, and XeF4 is molecular. Xe is xenon. Xenon is part of our noble gases. Noble gases are still considered nonmetals. So to name ionic compounds, we always name the metal ion first. Okay, so metal ions always come first in our ionic compounds, and then would come our nonmetal or our polyatomic. And we use its original name. If this metal is part of our transition metals or has, specifically if it has more than one possible charge, when you look up its name and it has two charges, we need to write the charge by a Roman numeral. So in the end, we'll write the metal's name, and then in brackets, we'll have Roman numerals. Roman numeral for 1, 2, 3. Once we get to 3, 4 looks a little different. 5, 6, and I think we would need to go to 7. Okay, make sure you know how to write a Roman numeral. And then we will follow with the non-metal, but we change its ending to "ide" if it's from the periodic table. If it's a polyatomic, we leave its regular ending. So let's name some of these. There's a couple examples in your notes. Let's go through. So KCl is ionic because K is a metal. K is potassium, so we just write its name as is. Potassium only has one charge, so no need to worry about brackets. Cl is chlorine because it's just straight up from our periodic table. It is not a polyatomic. We need to change its ending to chloride. So VCl5, V is vanadium. All right. So vanadium has two possible charges, so I'm going to leave a bracket for myself. Vanadium is mixed with chlorine, which again, we need to change its ending to chloride. Now we kind of have to get a little bit ahead of ourselves to answer this question. We need to decide which charge of vanadium is here. Is this a 5 or a 4? So we need to look to our nonmetal or polyatomic ion because they have very set charges. There is no nonmetal that has multiple charges. So let's look at chlorine. Chlorine has a -1 charge. If each chlorine is -1 and there are 5 of them, overall we have a -5 charge from all of our chlorines. That is balanced with 1 vanadium. Therefore, this vanadium must take on a full +5 charge. Is that a charge that vanadium has? Well, yes. Vanadium can have a +5 charge. So I'm going to put the 5 in the brackets because it is vanadium 5+ that we are using here. All right, MnO. Mn is manganese. If you look at manganese, when we were looking up its name, it does have 2 charges, so I need brackets again. It's mixed with oxygen. Oxygen is from the periodic table, so we need to change its ending to oxide. Manganese had 2 charges, so we need to decide what charge did oxygen have first. So oxygen has a -2 charge. There's only 1 oxygen here, so it had an overall charge of -2. That -2 must be balanced by manganese. So if there's only 1 manganese here, the charge must have been a +2. Now, you can write 2 like this in Roman numerals or like this. The difference is this is a capital and this is a lowercase, which is hilarious that numbers in Roman numerals had upper and lower case. Fun fact. Okay, let's keep going. K2CrO4. Okay, so K we know is potassium. Now, does it matter that there's a 2 here? Do I need to say that? No, I don't need to note that. Potassium does not have multiple charges, and these numbers come from the charges that are listed on the periodic table. So I don't need to say anything about this 2. You can figure out the 2 from charges. CrO4. So once I've named the metal, anything following either has to be an element, just one, from our periodic table, or a polyatomic. So because we have 2 elements here, this is a polyatomic ion. I'm not going to name this as chromium oxide. I'm going to look it up as a polyatomic. CrO4, which is a 2-, is chromate. So this is potassium chromate. PtCO3, which is in brackets with a 2. Pt is platinum. Platinum has 2 different charges, so I need to write brackets. Let's find out what CO3 is. CO3 is carbonate. Each carbonate has a charge of -2. Now, because we have 2 carbonates, that brings a total negative charge of -4. That has to be balanced by this platinum to make this all neutral. And because there's only 1 platinum, platinum must have a +4 charge. Is that a possibility for platinum? Yes, platinum does have a 4+ charge. Au3P. Au is gold. If you look at gold, gold has 2 charges, so we need brackets. P is straight up from our periodic table. It is phosphorus, so we need to change this to phosphide, changing the ending to ide. We need to decide what the charge is. So looking at our nonmetal, phosphorus has a charge of -3. There's only 1 phosphorus, so overall it brings a -3 charge. This -3 must be balanced by a total of +3 from gold to be 0. Now, this is a different case because there's 3 gold atoms that contribute to this +3 charge. Therefore, each gold atom must be +1. Therefore, this is gold 1-phosphide. Writing chemical formulas for ionic compounds. The net charge on the compound must be 0. Remember, we made our positives and negatives always add to 0 when we were trying to decide on charges. If there's more than one polyatomic ion needed to make the net charge equal 0, brackets must surround it before the subscript is added. We saw that with CO3. Rather than writing CO3-2, which would say that there's 1 carbon and 32 oxygens, the way that I just wrote this, we write brackets around it. So there's the quick and easy way of writing this, but there's also the full understanding way. I will do both because they both make sense to me. So cross and drop might be something you've heard before, the charges, and we're going to reduce subscripts. I'll show you what I mean. So magnesium chloride. What we need to do first is we need to find out what these elements have for a symbol and a charge. So magnesium is Mg2+. Cl is a 1-. So I can say we drop and cross by magnesium and chlorine coming together. This is technically a 1-, which we don't write. So I drop its charge to be the subscript for magnesium in my drop and cross. I'm going to drop and cross the 2 as well, and that would go here. So my technical, what I should write is MgCl2. I don't include 1s in my formula. How we could do this by just thinking about making something neutral. If this is a 2 positive and this is a 1 negative, I need 2 of our negatives to balance to make 0. So this will become MgCl2. So the number of atoms that we need to balance the charge becomes the subscripts. Let's try aluminum sulfate. Aluminum is Al, and it is a 3+. Sulfate, 8, tells me that it is not straight up from my periodic table. Ide is from the periodic table. Therefore, I need to find the polyatomic ion sulfate. Sulfate is SO4 2-. Now, if you want to think about this just in terms of making this neutral, a 3+ and a 2 negative don't add up to 0 together. I need to multiply this one by 2 and this one by 3 to get 6 positives, 6 negatives, which add to 0. So to write that, I would say Al2, I needed to multiply it by 2, SO4 3. Now I don't want to write SO43. I need to put the SO4 in brackets when there's a 3. If you don't know what I just did and you want to drop and cross, that is A-OK. So drop the 2 to aluminum and the 3 goes to sulfate. Because it needs a multiple, we have to put it in brackets. Either way, we get the same answer. Next up is niobium or niobium 5-cyanide. So niobium, where is it on our periodic table? Looks like it is atomic number 41, and its elemental symbol is Nb. The 5, Roman numeral 5, tells me it's niobium 5+. Cyanide is not actually an element. It is a polyatomic. So looking up there, cyanide is Cn negative. So to balance the charges, this one has a 5+. I need 5 times our -1 to balance this out. Therefore, we should write this as NbCN5. Again, cyanide is a polyatomic, so I need to say put it in brackets. Otherwise, I'd write this, which doesn't mean cyanide. CN5 is not cyanide. So this is incorrect. Ammonium bromide. Remember I said ammonium is NH4+, and it acts like a metal because it's a positive ion. Bromide is Br-. Positive and a negative totally cancel one another out, so we get NH4Br. Naming molecular compounds. So with molecular compounds, we do not worry about charge. So it doesn't matter what the charge is. What we need to do is we just need to say how many of each element is there or in our compound. So you need to remember these prefixes for 1 through 10. The nonmetal with the lowest group number, or that is furthest left, is usually named first, and the element with the higher group number is put second. If you're looking at a chemical formula, it's always been written this way to begin with. The second element, its ending is changed to "-ide", just like we would in a ionic formula. We just need to add these prefixes along with that. There are a couple exceptions. If oxygen is combined with a halogen, the halogen is named first. And if oxygen is named second with the "-ide" ending. And if the first atom listed has a mono prefix, so there's only one of our first element, we don't write mono, it's just implied. So let's look at a couple of examples. Let's say, I'll just make these up on the fly here, P2F5. And we will do CF4. So in this case, our first one here, we name our first element. So the first element is phosphorus, and because there's two, we need to say diphosphorus. And then, I shouldn't have had that O there. And then 5 fluorines means pentafluoride. Okay, the ending of fluorine is changed to "-ide". So in our next one, the first one is carbon. Because it would have had a mono, we drop the mono, it's just carbon. And we have 4 fluorines, so we are going to say tetrafluoride. There are some compounds that have names that need to be memorized. So you need to memorize these 6, including their state. Naming acids. In this case, typically when I'm naming acids, I'm looking for the classical naming. So when you hear hydrochloric acid or sulfuric acid, you're hearing the classical name. IUPAC would have been hydrogen chloride or hydrogen sulfate, which isn't really what we use in common language for chemistry. So we're looking at classical naming for acids, whereas we were using IUPAC rules for ionic and molecular compounds. So there's 2 systems, like I just said. There's IUPAC, and so we name it like it's an ionic compound. And then we're using the classical where we have these suffix, which are endings. So there's 2 different kinds of acids. There's a binary acid and there's oxy acids. A binary acid is hydrogen and 1 element. So HCl or H2S. An oxy acid is hydrogen and a polyatomic ion. So hydrogen mixed with any of the polyatomic ions in the top of our periodic table. So that's sort of be H2SO4 or HNO3. We also, within an oxy acid, there's organic acids. They're still polyatomic, so you can find CH3COO-. The H just goes on the end when something was COO. Remember, it typically goes out front, except in the COO case. For naming these, again, IUPAC is not really what we're going to use here, so don't worry about that. What we're going to use is the classical naming format. So for a binary acid, so that was hydrogen and an element, we're going to put hydro, whatever that element was, ic acid. So for instance, H2S is hydro, sulfuric acid. So we just put sulfur, the element, in the middle there. For HCl, we have hydrochloric acid. Oxy acids, again, are hydrogen with a polyatomic. So we would have whatever the polyatomic's name is in each of these places. All right, if the polyatomic ended with 8 to begin with, so for instance, chlorate, this would become chloric acid. An example here, we have SO4, which is 2-. This is sulfate. Because the polyatomic ended in 8, we change its ending to ic and add acid when it's combined with hydrogen. If the polyatomic ended in ite, so for instance, sulfite, we change the ite ending to OUS and add acid when it's combined with hydrogen. So SO3 was a 2-, it's again sulfite. So we change ite to us and add acid. A few people remember this as hide, hickey. If you ate something, you might say ick. And if you bite, if you bite something, it might be poisonous. All right. So hydrogen, what these mean, I'll go through them. Hydrogen with an "ide" ending. So again, that would have been just an element. We have H and ic. Okay, hydro and ic is what that's trying to say. Now, if you have a polyatomic that ended in 8, you might say ic. And if you bite something, it might be poison us. Those are just reminders of the endings in case you don't want to look this up every time. So for homework, complete the questions on naming in your review booklet. There is a full answer key, so make sure that you're checking that throughout.